Welcome to Module 2, and this is all about energy and astrophysics and the connection between the two, the amazing connections between this stuff. In this first part here, we're going to do a little bit of an introduction to energy, what it is and the forms of energy, and how we're going to use that as we work through our physical science and earth connections. So first, what is energy? So we must define this concept so that we have a foundation to go on as we move through this module. Well, thanks to a hybrid definition between some information from Northwestern University, Wikipedia, and a little bit of my own brain, energy is the quantitative property that must be transferred to an object in order to do work, notice that's underlined there, on that object. Otherwise, move against a force. So it's the quantitative property that must be supplied to an object to move that object against some force. Okay, that's the general look at this. And if we take this one step further, we can understand that energy comes in many forms. Kinetic, potential, some of the common words you might hear have already heard around energy. Thermal energy, light energy, chemical, electrical. These are all just types of energy that we're going to take a little further of a look at in just a minute. But before we jump into all the different types or the forms of energy we will encounter, we must understand one of the most vital and fundamental laws in science, and that is the law of conservation of energy. And you may have heard this law of conservation of mass or energy. You might have heard this before. And what this law is, and note it's a law. It's not theory. This is a law. This is the real deal. Okay, this is pretty locked in here. This states that energy is conserved over time. It cannot be created. It cannot be destroyed. In a way, it exists as it is, and it can only be transformed into other forms of energy, or it can be transferred to other objects. Right, so the forms of energy can kind of go between each other through this transformation process. Okay, so the light bulb example here, over to the right, this shows us electricity or electrical energy coming in through the wires to turn on this light bulb. And then the energy being pumped in this object is then transformed into light energy through this filament, and that's given off for us to see. So this light energy is all this new transformation of the electrical energy, and also heat energy is kind of produced as a byproduct, and that's transferred into the surrounding air. Right? But so we see that it's transferred. Okay? But of course, the amount of electrical energy that was provided to the light bulb initially has to equal the amount of light and heat that is then produced based on this law of conservation of energy. So total energy in an isolated system is conserved over time, cannot be created, cannot be destroyed, but it can be transformed or transferred. So that's a very general look at the law of conservation of energy. For a deeper look at this, you could try the Khan Academy video. It's seen below here. It's also linked in the resources pages. But if you'd like to further your learning a little bit, this is a great resource to utilize. All right, so forms of energy. Okay, what do we got? Well, we're going to separate these into two main categories first. We have kinetic, which pertains to the motion of objects, generally speaking, because that can include macroscopic objects. Okay, that can include me running, a car moving, right? Or microscopic objects. We're talking particle motion and maybe the motion of sound waves and such. Okay, the second form or category we're going to put out here is potential. That refers to anything with stored energy, such as the energy stored in the bonds of chemical compounds. But it can also refer, and you're going to see it a lot coming up, it refers to the position of an object or particles given a specific frame of reference. Okay. So with these two types of energy as our main overall categories, we can begin to examine other types of energy that you've probably heard of many before, and we can sort them into these two categories or as some kind of combination of the two. You'll see what I mean in a minute. And this is an important relationship to note in that energy can manifest itself, especially microscopically, stuff we can't see, as a combination of motion of particles, but also the positions of particles in relation to one another. Okay, so let's look at some more examples that are going to fall into these categories. The first one we have mechanical energy, and that's true motion of objects, macroscopic, microscopic, or even invisible to the human eye, right? Waves, cars, okay, all things that are moved by some force, okay, that involves work on something, that can fall under mechanical energy. Next up, we have thermal energy, or the type of energy that comes from heat, which develops from the motion of particles. So, depending on temperature, right, particles move at different speeds and will exhibit higher or lower levels of energy. Now, note the asterisk on both of these first two, and that's because these two can be said to fall in that whole combination window of the two different types of energy, as both mechanical and thermal can be defined more as the sum. All right, the sum between the kinetic energy, or the motion of the particles or objects, and the stored potential energy based on the position and arrangement of said objects. So if you'd like to extend your learning on energy and what I mean here between the sum of these two types of energy, the resources page again has some other great videos with great information on energy, especially when it comes to these kind of hybrid summations of kinetic and potential. Next up on the energy identification train, we have electromagnetic energy. And these are the types of energy that fall on the electromagnetic spectrum: radio waves, electrical waves, X-rays, ultraviolet radiation. All right, and we can even include visible light here. All the types of energies that are going to be emitted from an energy source, such as our star, our sun. Okay, that's electromagnetic waves, or even you could classify it as electromagnetic radiation. And then a similar one that may kind of synonymous with electromagnetic energy, that's called radiant energy. It's more so the energy given off by electromagnetic waves, so light energy. It's one of the prime examples of radiant energy, such as the sunlight that we get every day of our lives, unless you live in really dark places where the sun doesn't shine for a little while. Next up, we have sound. Okay, sound is a type of energy, of course, you're going to come across. You're experiencing it right now as you listen to my voice. And sound technically falls under the category of mechanical, as it's a vibrational mechanical movement of waves, right? But we can kind of mark it as its own entity for now under the kinetic category, just so we can make sure we see all these different examples you're going to see. But again, sound could be said to be classified under a mechanical sort of energy. And then we also have electrical energy, which again can be kind of classified within a mixture of these. And these are all open to interpretation. If you see one, you're like, that seems like it would be more grouped there, or I thought it was more like that. You're probably absolutely right, because a lot of these forms of energy are kind of intertwined, and they can be grouped together depending on how they manifest themselves. But electrical energy is all about the movement of electrons in order to create electricity. All right? Now, for potential energy types, we are starting with nuclear energy, which, again, this is one of those ones that's kind of in a category of its own, considering the majority of nuclear power and energy is man-made in nature. But this is energy created from nuclear reactions, and that energy is then stored and transformed into other forms of energy to help power our worlds, right? But nuclear kind of can sit in that potential category because of the storage of the energy. All right, gravitational energy is up next, and this is, of course, related to gravity, or the force that our planet exerts upon all of us to keep us all, and quote, down to Earth, right? So gravitational energy refers to the amount of potential energy within an object based on its position, or its higher position when compared to a lower counterpoint. Example, me holding a ball up in the air, or you holding a ball up in the air, and then releasing it towards the ground. The ball has a large amount of gravitational potential energy at the top of the hold when you're up above your head, but when you let go, that all converts or transforms into kinetic energy as it falls through the ground using the acceleration due to gravity, and then it hits the ground and stops motion. So it's a lot of potential energy transferred to kinetic, and then based on where it lands, it could then be said to transfer back to potential energy. Again, stored energy, not energy of motion. elastic energy is one of the lesser common types, but yet still something to think about. Elastic energy is the energy found stored in any coil-based structures or any object that can be compressed or stretched or deformed in any way. That's going to fall under the category of elastic potential energy. And the last one here we have is chemical energy. And I've noted this already, but this refers to the stored energy found in the chemical bonds between atoms that are found in chemical substances. And that energy is the energy that leads to a lot of chemical reactions. And the potential of these substances to undergo chemical changes and transformations, or when you see something, light on fire, these are chemical energy stored deep inside these bonds that are then being released during these chemical reactions, or again transformed, right? And so those are the categories and the different terms you'll see and types of energy you might see, and how we could attempt to group these. But again, these are kind of up for interpretation a little bit, as many of them fall into multiple categories or can be grouped together in other subsets within these categories. Okay, so if you want to further your learning, check out the resources page to get even more. So a quick summary, right? Definition of energy: the quantitative property must be transferred to an object to do work on that object or move it against a force. All right. The law of conservation of energy, of course, says it is conserved over time. It can't be created. It can't be destroyed. It can, however, be transformed or transferred. And there's many different forms of energy which can all kind of intermesh and interweave together and can be kind of summations of multiple ones together. And so energy, it's a very complicated but yet very exciting topic. And that's it for this part of the video with your energy introduction. Next up, we're going to look at the equations that are around energy and how we can calculate and apply some of these new concepts.